Well, I think the biggest challenges ahead as we look to develop 5G vision are, in my opinion, one, you're going to have to develop the standard, agree the standard, and then and to do that, obviously, you have to look at developing specifications and so on. Now, part of the challenges you'll face is getting everybody together, all the stakeholders in the industry, agreeing what should be the standard for 5G. Now, doing that, then the next thing is removing the impediments. What are the impediments to deployment of 5G? Issues of, for example, spectrum is another issue. What spectrum should be allocated? When should it be allocated? Can you get consensus among countries at the ITU to make the allocation, say, in the coming conference of 2019? But before that, before you even get there, you have to agree an agenda item on the conference coming up in November to say this should be on the agenda for 2019. Now, once that is done, at least you can now discuss the process, you can do the studies necessary to allocate the particular spectrum. Now, they were talking about two kinds of spectrums here. One below 6 gig, but also above, that is between 6 and 100 gig, that's 100 gigahertz. Now, that presents another set of challenge. Below 6 gig, of course, we can have transition between existing technologies like 2G, 3G, 4G, and so on. And after 6 gigahertz, then you'll be talking about probably new radio access network. That in itself presents a set of challenges. Because what are we looking at when we say 5G? 5G, we're talking about low latency. We're talking about good connectivity. We're talking about good coverage. We're talking about high speed, beyond 10 gigabits per second. Now, to achieve that, obviously you need high spectrum because it's laws of physics. And you know that you have to have many ones and zeros over a waveform. The higher the spectrum, obviously the more ones and zeros you can put, depending on the power you ramped up. Now, we are also talking about getting power down. That's another challenge. How do you get power down when you want to carry more bits over that waveform? So, it's lowering power, and as well as getting more data, getting the compromise there is another challenge for 5G. So, and also they're talking about low cost. How do you get low cost when you're trying to ramp up the power? That's another challenge. So we have to develop one new kind of set of antennas, advanced MIMO antennas that will take more data across different channels that will communicate, that is to say, between antenna and the device. Now, we're also talking about latency, very low latency, less than 1 millisecond. How do you get less than 1 millisecond latency? Obviously, with laws of physics, you know that if you're going to communicate via internet across distances, there are obviously delays along the line because there are, if it's dispersion sometimes in the air, or even if it's fiber, you still have to get dispersion. So that will cause some delay of the travel of light or travel of electromagnetic signal. So to get that low latency, you're talking about getting content closer to the end user. How do you get content closer to the end user? It means you have to have more costs, you have to have deployment, you have to have even switching at the station. Now, these are some of the few challenges I can mention here that will impede progress, but the most important thing is getting people together to sit down and agree what should be the standard of 5G, what is 5G in itself, what should be delivered. Is it going to be low latency only? Is it going to be low power? Is it going to be better coverage? Is it going to be high speed beyond 10 gigabits per second? Is it going to be higher data per square kilometer? All these are issues that we need to agree as to how to go about it. Once that's agreed, then the other steps can follow. Well, what are the new services and applications that 5G is going to enable that is not currently available? I think that's a very good question. Now, you've got to understand, have to differentiate what are we looking for when we're talking about 5G. Now, when we're talking about 5G, what comes to mind are the new applications. Of course, the LTE that we have today can enable good communication, but if you like virtualization, conference calls and so on. But the applications that require very high speed are, for example, cars, connected cars. How do you get? Today we don't have connected cars that are moving, the cars turning into, if you like, microcells. All those we don't have. We don't have, if you like, virtualization. When you have, if you like, or rather augmented reality and so on, whereby you can communicate almost seamlessly with very low latency. You can get content. You can have conference call that is. You can still do conference calls with minimal latency, but to get, very, if you like, almost near reality, or large group of people communicating from different parts of the world together, then that is where 5G will enable that. Probably you're not getting as the best of that, but getting all the machine-to-machine communication, so many devices. Today we have 250 million devices connected. We're talking about over 2 billion devices going to be connected. That is not enabled today by the current technologies, because as the number of devices increase, the more data increase. That means there's a limit to what you can accommodate in a particular spectrum. Therefore, you need to go to higher spectrum, which is actually now envisioned to be serving 5G. So the more devices you have to interconnect, homes, cars, machine to machine, machine to human, and so on. All those things are going to be enabled by 5G, which we are not getting today.